In this video, we are going to introduce relations and functions, and we're going to do that by using a foldable. So let's set up our foldable first. You take your piece of paper like this, and you're going to fold the left-hand side into that middle line, and fold it, and then take the right-hand side, fold it into that middle line as well, and fold it. We have some cutting to do as well, so if you open it back up, along each of these solid lines, you are going to cut all the way to that fold that you made, but not past it. I'm going to cut here, and here, and here, and here. And we're going to do that on the other side as well. So you flip it over, you'll cut to that folded line. And then we will also cut out any of the pieces that do not have any writing on them. So for example, this piece right here doesn't have any writing. I'm going to cut along that folded line there. This has writing, so I'm not going to cut that. It has writing, I'm not going to cut that, but I'm going to come down here, cut out this tab right here, so I don't need that. I'm going to do this on the other side as well. So this tab right here doesn't have any writing. I cut that, so we have it looking like that. So when I fold it in, you can see that. And here, this has writing, so we're going to skip it, but we are going to cut off this bit here. So now we have a foldable that looks like this, and I can open up the tabs and see what's inside. Alright, so I said we're going to introduce relations with this video, and so we're going to start at the top. A relation is a relationship between two sets of information, inputs and outputs. And as we do this lesson, I'm going to highlight all of the inputs in purple and the outputs in blue. So relations can be represented in multiple ways. So we're going to start with a table. So I'm going to open, before I open this up, we'll label this. This is tables. So we'll open up tables. It says the input is often X, so we'll underline that. The input is X, the output is Y. And it says that if you are given an equation to represent the relation, you can substitute inputs, values of X, into the equation to find the corresponding outputs, values of Y. So let's talk about what that looks like in order, before we dig into the table. So this is a representation of a function rule. We said equation, so often a rule can be written as an equation. So I will write that as y equals 1/2 x squared minus 5. And so what we have is we can have an input, that'll be our x value, and let's just say we choose an input of -5. So -5 is going to be our input. And when we put that into the function, wherever we see the x, we'll put in the -5. So we will do our 1/2 times whatever the input is, squared minus 5. In other words, if I show my work below here, I'll have 1/2 times -5 squared minus 5. And then I simplify using order of operations. First, I will do with the exponents. So -5 squared is 25, so I'll have 1/2 times 25 minus 5. Then I deal with the multiplication. 1/2 times 25 would be 12.5. And then finally I subtract and I get 7.5. So my output, or the y value, is 7.5. So if I go back to my table, I can write my table here where I have the input of -5 has an output of 7.5. Now I could do that for another input. I can choose whatever I want. So let's choose -2. Let's choose an output of, an input of -2. Well, when the input is -2, I now replace my x with -2, and when I simplify this, I have 1/2 -2 squared, or -2 times -2 is a +4. 1/2 times 4, well, to the side I can do this side work, I can do 1/2 times 4 over 1. And 1 times 4 is 4. 2 times 1 is 2. 4 divided by 2 is 2. So I really have 2 minus 5, which is -3. And so the output here would be -3. And I can go back to my table and can fill that in. Now, I could have other inputs as well. So an input of 0 is going to have an output of -5. We could say an input of 2 has an output of -3. And an input of 4 has an output of 3. So one of the ways that we can represent this relationship between x and y was that equation. Another way is this table. Now, if you have a table, you can also write this table, the relationship between the inputs and outputs, as a set of ordered pairs. So to the right, let's label this ordered pairs. We open that up and we say that the inputs, or the x coordinate, is written first, and the output, or the y coordinate, is written second. We use parentheses around the coordinates in an ordered pair, and we write the sets of ordered pairs in braces. Let me show you what that looks like. So we have, that's a brace to say that this is a set. And we take this table and we will write -5, the input, and its corresponding output. And then we can say -2 is the input, its corresponding output is -3. The input of 0 has an output of -5. The input of 2 has an output of -3. And the input of 4 has an output of 3. And then we close those braces. These braces indicate that those 5 ordered pairs go together. They are a set. And each of the ordered pairs is separated by commas. And so again, the input is always the first coordinate, and the output is always the second coordinate. We call these x and y coordinates. Now, from points, you can also create mapping diagrams. And mapping diagrams just are a different representation for how to connect the input to its output. So we'll go down here, we'll write mapping diagram. We don't often see mapping diagrams in mathematics, so this may be new to a lot of us. So in mapping diagrams, the left box or oval has all of the inputs. The right box or oval has all of the outputs. And we don't repeat any of the input values or output values when we write them. So for example, all of my inputs, the inputs are -5, -2, 0, 2, and 4. And then in the outputs box or circle, I write all of the outputs. Well, I notice, I'm going to start with my lowest just to make write it in increasing order. So we start with -5, then we have a -3. Now I see -3 twice, or -3 twice here, but I don't need to write it twice in the outputs. And we'll show you why in a second. And then the next number in increasing order would be 3, and then 7.5. And so what you do for a mapping diagram to show which input corresponds to the output, you start with the input, and I see the input of -5 has an output of 7.5, so I draw an arrow to that. Or I could look at the ordered pairs over here and say, okay, well, -2 has an output of -3, so -2, I draw it to -3. 0, the input of 0 has an output of -5, so I go from 0 to -5. And then 2, I can go back to the table, you can look at either representation. The input of 2 has an output of -3. So notice that that output of -3 happens twice, but I just have to draw 2 arrows to it. I don't need to write the -3 twice. And then finally, my input of 4 has an output of 3. And so this is our mapping diagram, and the arrows show which input goes to which output, or which output corresponds to the input. So we have a table, we have a set of ordered pairs, we have mapping diagrams, and we can also represent relationships between inputs and outputs using a coordinate plane. And a coordinate plane is a type of graph. We have studied many different types of graphs. A coordinate plane is one type of graph. So let's open that up. We see that the x-coordinate, that's our input, tells us to move horizontally, left or right. If the x-coordinate is negative, we'll move to the left. If the x-coordinate is positive, we'll move to the right. And then the y-coordinate tells us to move vertically. So if the y-coordinate is positive, in other words, if the output is positive, we're going to move up. If the output is negative, we will move down. So we can go from any one of these. Let's start here. -5, 7.5. Well, that -5 is our input, so it tells us to go to the left 5. 1, 2, 3, 4, 5 to the left. The output is 7.5. It's positive, so we're going to go up 7.5. 1, 2, 3, 4, 5, 6, 7, and 0.5, right between 7 and 8. Or let's go to the ordered pairs. -2, -3 means -2 tells me to go left or right. It's negative, so I'm going to go left. The -3 tells me to go up or down. Because it's negative, I'm going to go down 3. So there's my another point. Or go to the mapping diagram. We already did the input of -5 and -2. Let's go to 0. The input of 0, meaning when x is 0, the output is -5. Y is -5. Now, because x is 0, I'm not going left or right. I'm staying right on this y-axis. And then I'm going to go down 1, 2, 3, 4, 5. And then moving on to 2, -3, I go right 2 and down 3. 4, 3, I go right 1, 2, 3, 4, and up 1, 2, 3. So this is a relation modeled by a graph. So all different ways to model relations. Now I want to talk more specifically about another vocab term. It says a special type of relation is a function. And in a function, each input has only one output value. I want to highlight this because this is really important. Each input has only one output value. We're going to talk more about what that means, but I want to use this definition now to look back here, and we see that the input of -5 only goes to 7.5. You don't see -5 going to any other number. We're looking at the mapping diagram. -5 has only 7.5 as an output. So that's what that means by each input has only one output. You don't see -5 going to 7.5 and to 3, for example. All right, so scooching down here, if we open up to the left, it says the input is often represented by x. The domain is a set of values used for the inputs of a function. So I'm going to underline domain. That's going to be an important vocab term. So when we look at this relation here, you can look at any representation. If we're listing the inputs for the domain, because we're talking about a set, we're going to use set notation using the brace. And now we're going to list the inputs in order of from increasing order rather. So -5, -2, 0, 2, and 4. So if I asked for the domain, this is how we would write the domain of the relation above. And the variable that represents the input is the independent variable. So if I flip here, the vocab term we want to put on the front here is inputs, and then in parentheses, domain. Over here, we're now going to talk about outputs, or range. So let's open that up. The output is often represented by y. Y can also be written as f of x. So let's write that in here. This is red, f of x. And we're going to talk more about this later. This is called function notation. The range is a set of values used for the outputs of a function. So if I asked you for the range, because it's a set of values, we use set notation or a brace, and we go back up here, and you can look at any one of the representations. You can look at the outputs, the y values in the table, the y coordinates of points. You could look at the y values for these points here. However you choose, but we now need to list them. Now notice that we have -3 is an output for 2 different inputs. So when we list this, one thing that we have to be careful of is not only do we write in an increasing order, but we also write this, you don't write any number more than once. Kind of like how we did over here in the outputs for mapping diagrams. So we're going to start with the lowest number, -5, -3. Even though -3 shows up twice, we're not going to write it twice. 3, 7.5, and then we're going to close that brace. And that would be considered the range of the function. The variable that represents the outputs is the dependent variable when we're talking about relationships. All right, so that is our introduction to relations and functions.